SQL is strange till you like use it a few times and you're like, oh, this is like really pretty nice, kind of works. But obviously like about like Postgres, about like database tables, that like each table has like mini columns, right? So we could have like table 1, this has like A, B, C. And the reason why like you have a database is just to keep all the data safe and to have it be stored somewhere, essentially, with quick read access and write access, right? That's the whole point of the database. The whole point of the API is just expose an interface to talk to the database. So like really the API is just like your friendly interface for accessing whatever is your goodies in here. For example, we'll start using a different table example, but we'll say this one is like job posting. Here we have like salary, role, and company, right? Each job posting has an ID and maybe like a source URL, and then we have job applications, and this will be member ID, job posting ID, and that's pretty much it, right? Maybe like submitted at and some other stuff.
Yeah, and that's like the table.
And this is a table, but Postgres and SQL and everything is relational, as you know. So you store data in relations using foreign keys. So this job posting ID is a column, which is a foreign key that references this primary key. And now we have our data in a structured, reliable, consistent way where we can build an application around it, right? And so like, for example, let's say I want to build the hiring funnel app where Hiro logs in and you can see all the jobs I applied to for him. Then I'll just have like a get applications by member ID route with maybe like member ID. And then I'll just literally the entire point of the API is just to get the data from this table where this filter, right? So working with like the database stuff is like a pretty important part of the backend because I don't know, that's most of what like web development has been for the past 20 years. It's just like storing data and then building a UI around it. But the foreign key relation gives us quick references and ways to like visualize and understand relationships where I can do these cool things. Like I can create you a screen where it's just your job applications, right? And then like, for example, if I wanted to return to the screen all of the job applications that I applied for you and also source URL, this is a very common thing you'll run into in writing APIs and database queries is that we have the job applications table with these 3 rows, right? X, Y, Z. But in our front-end UI, the mockups, they have this additional requirement. They need the source URL, so you can click on the link and see the job posting. Now we're grabbing data from this table, but we also need to grab a column that we're referencing. That's the whole point of joins. We're going to join the data together in one aggregate way where we've got the columns we care about from this one, and we got the columns we care about from this one. So what this will look like is like select job application, inner join, job applications dot job posting ID is equal to job posting dot ID. And then from here, we want to select the source URL, the submitted at, and whatever columns we care about, right? So we're joining the 2 distinct data sources into a view, into an interface that meets our requirements. The reason I joined it like this is because it's the foreign key constraint, right? I'm saying this column means something. This means that there's a foreign reference and there's a record that exists at this ID, and that these 2 belong together as a relationship. From ChatGPT, right join returns all rows from one table and matching rows from the left table. No match columns, null. Left join returns all rows from the left table, so vice versa. Inner join returns only rows that have a match in both tables, and outer returns all from both. So it's just ways of saying like, how much data do you want me to return from this aggregate view that you're building of this relationship?
So I guess it depends on when you want null values, essentially.
Someone might ask you this stuff if they're trying to dig deep in an interview. But pretty much like, there's 2 different database tables, right? There's job applications and job postings. And it's like, what should we do when there's a match, what if there's no match, and how much data do you want returned? So for example, let's start with this first one, inner join. So this only returns job applications that have a matching job posting. So for example, I submitted applications for you on LinkedIn before I built this web app, and those don't have a corresponding record. So those would all get dropped from the data set in inner join, right? Because there's not a corresponding record, that means I don't want it. Left joins, even if there is no corresponding record, it'll still return it, but the LinkedIn jobs will just say null. Right join returns all, even if none exist. Show all, including this application's application info. Right join. So like this will pretty much just return everything, and it'll still be null if there's no data.
Okay.
Well, outer join returns everything. What this builds is like a intermittent table, where it's like an intermittent table is source URL, member ID, submitted at, right? Literally just that. And then now you're doing filtering and conditional logic on this intermediary version structure of the data that is more consistent with what you want. For example, let's say I have another table and it's called like Hyro's job feedback. And on job posting ID, you give me feedback like, hey, this job says like senior director, VP, that's too crazy, right? Now I have another query where I'm trying to get job applications so that I can apply to them for you, but I don't want any that you've given me feedback on, right? So now there's logic in my query that I have to join on this table to see if you've left me feedback before I fetch it. For example, you submit a change request for like a security policy, right? Then there's like another table that's like an intermediary state where like it's pending approval, right? Like it hasn't been approved yet, hasn't been denied yet, it's pending approval. So we need a join to check the pending approval table, right? So that our application can function as like an approval process. Also like pagination, like we talked about, like we don't want to throw 5,000 things at the DOM because then it'll blow up. So this is one way where you can like kind of build a intermediary table data set and scroll through it with like a pointer rather than returning the whole thing, right?
Yeah.
I appreciate it, dude. Look forward to talking next week.
Cool. Sounds good. Peace out. Hope you take a break later, man.